So in this question, two stationary point particles with equal and opposite charges are at some fixed distance from each other. So two equal and opposite charges separated by a distance. It means it is a dipole. It means it is a dipole. Equal and opposite charge separated by a distance. Okay, let's say it is d. Let's say distance is d. And further, points having zero electric potential lie on. Okay, so point where potential is zero. Where potential is zero. We have to tell such points where total potential is zero. So total potential at any point will be either due to plus q and either due to minus q, because only two charges are the source for potential. So let us first write potential due to plus q, that is given by k q over r. Let's say it is r1. So plus q is r1 distant apart at that point where potential is zero, and potential due to negative charge is minus k q over r2, and negative charge is r2 distance apart from that point where potential is zero. Okay, so total potential is zero at that point. It means potential due to plus q and potential due to minus q is also zero. Combined potential is also zero. So I can say potential due to plus q and potential due to minus q is zero at that point. Okay, so I can also say that k q over r1 minus k q over r2 is also zero, and from this equation I can say r1 equal r2, r1 equal r2. So this is the condition. This is the condition where potential may be zero. Potential due to plus q and minus q may be zero. This is the condition. It means the points should be equidistant. Equidistant from plus minus q, from both of the charges. It is equidistant. So only one case is possible. Sphere is not possible. Cylinder is not possible. Only a plane is possible. How it is possible? Let's say this is the plane. This is the plane, and it is bisecting this axis at midpoint. Bisecting at midpoint. Bisecting at midpoint and perpendicular to dipole axis. Okay, perpendicular to dipole axis. So if I assume any point on this plane, that will be equidistant from both of the charges, this r1 and r2, always equal. So every point I assume on this plane will satisfy this condition. So B is the correct option for this question. In this question, 2-point charges plus q1 and q2 are separated by a distance d. Okay, and it is desired to put a third charge q3 in between these two charges on the line joining them, so that q3 is in equilibrium. Q3 is in equilibrium. This is possible only. Q3 is positive, Q3 is negative, irrespective of the sign, either plus or either negative. Okay, not possible at all. So in this question, two charges are given, Q1 and Q2. Both are positive, separated by a distance d. Okay, so we have to put a third charge Q3. We don't know either it is negative or it is positive. We have to put this charge on this line, on this line, such that Q3 is in equilibrium. Let's say we put Q3 here, and it should be in equilibrium. So if Q3 is in equilibrium, so net force is 0. Net force is 0. Okay, so first assume Q3 is positive. Okay, if Q3 is positive, so force due to Q1, force due to Q1 on this Q3. Okay, force on Q3 due to Q1 will be in this direction, and force due to Q2 on Q3. Force on Q3 due to 2 will be in this direction, and these are opposite forces, and they may cancel out each other. They may cancel out each other if FQ32 equal FQ31. So it means it may be in equilibrium if these two forces are equal. Okay, and the second case is Q3 is negative. It is negative. If it is negative, so direction of these forces will become interchange. So let's say this is Q3. If this is negative, so this will be attracted toward force on Q3 will be attracted towards 2, and force and Q3 charge will be attracted towards 1 as well. So this may also be happen. Force on Q31 and force on Q32 are equal. In such case, these forces may cancel out each other, and net force on Q3 is 0. F is 0. This can also be happen. So either Q3 is positive, Q3 is negative. Okay, condition may satisfy. And the third option is possible irrespective of the sign. It means either it is negative or either it is positive. Condition is fulfilled. It means C is the correct answer. Shape of dielectric lamina. A lamina is given, which is defined by these two equations. Okay, and also surface charge density is given, and what is asked? Total charge. Okay, total charge on the lamina in Coulomb, it is asked. So given is lamina which is defined by these two equations, y equals 0, which is x-axis. Y equals 0 is x-axis, and another is y equal 1 minus x square, which is equation of parabola. Okay, and origin is 0 and 1. This is the origin. This is the origin. And sigma is given. Sigma as a function of y is given 15y Coulomb per meter square. And what is asked? Total charge is in Coulomb. So sigma, as we can write dq over dA, dq over dA. Okay, and from here dq I can write sigma into dA. Okay, and if I integrate this equation, so this will give me q and sigma dA. Okay, so this integration we have to solve with the help of these two equations. So let us first draw these two equations. So first is x-axis, first equation. This is y equal 0. Okay, and parabola is on is on y-axis. Okay, so it is y equal 1 minus x square. For y equal 0, x is plus minus 1. We can solve it. We can solve and get these values easily. So this will be something like this, parabola. This is minus 1 to plus 1. This is 0 and 1. Okay, so this area, if we know, and it will be multiplied by sigma, then total charge we can calculate easily. So let us first limits. Okay, and before that, because this is in 2 dimension, so dA we can write as dx and dy. Okay, and integral becomes sigma as a function of y, dx and dy, because this is a double integral, so I have to make another one integral sign here. Okay, so what will be limits of x and y? So x is from minus 1 to 1. Limit of x is from minus 1 to 1. And for y is starting from 0 to this is very important to learn this point. First let me make a note. For every fixed value of x, okay, so y is given by 1 minus x square. So for this value of x, suppose x is from minus 1 to 1, corresponding to this y is given by this function 1 minus x square. Okay, so we have to write the limits in such a way. Okay, so whatever value of x in limit I am using, and corresponding to that x value, y limit is put there. So I can write x is from 0 to x is from minus 1 to 1, but y is from 0 to 1 minus x square, because this is a function. Okay, after putting this x value, this will give me y value, which is going to be upper limit. Okay, so I can write this integral, that is q equal with 0 to 1 minus x square minus 1 to 1. Sigma y is 15y dx and dy. So I have to solve this integral. So let's solve it. Q is given by from 0 to 1 minus x square, from minus 1 to 1. 15 I can take outside from the integral, and this is y dy and sorry dx and dy. So integrating 4x first, this will be 15, 0 to okay, this is minus 1 to 1, and y square divided by 2, limit is from 0 to 1 minus x square and dx. Further 2 I can take out from the integral. This is minus 1 to 1 and y square. So upper limit is 1 minus x square whole square, and lower limit is 0, so it will be 0 dx. Okay, and in this graph we can see that the half of area in the second quadrant is equal to area in first quadrant. So if I multiplied this area with 2, this area, I can get total area, because this is symmetric and equal in both of the quadrants. Okay, so what I will do, I will do 15 by 2 multiplied by 2 and from minus 1 to 0. Why minus 1 to 0? Because limits of this area, the shaded one, is from minus 1 to 0, and I'm multiplying it with 2. Okay, so that's why I've written here minus 1 to 0 multiplied by 2, 1 minus x square dx. So 2 will cancel out. So total charge will be equal to 15 and minus 1 to 0. Okay, this is whole square here. So open the square, 1 plus x to the power 4 minus 2x square and dx. Okay, 15. 1 x plus x to the power 5 divided by 5 minus 2x3 divided by 3, and this is minus 1 to 0. Okay, 15. If I put 0, everything will become 0, and minus, if I put minus 1 here, so this will be minus 1, this will be minus 1 upon 5, and this will be plus, because minus 2 multiplied by minus 1 upon 3. Okay, and q will become 15 multiplied by plus 1 upon 5. This will be minus minus plus and minus 2 by 3. Okay, so 15 LCM will become 15, and this will be 3, this will be 15, and this will be 15 plus 3, and minus 10. Okay, so this will become 15 multiplied by 18 divided by 15 minus 10. 15 will cancel out, and this 18 minus 10 will become 8. So Q will be 8 Coulomb. Q will be 8 Coulomb. Okay, so 8 will be answer. So in this question, for infinite wire, lambda charge density, linear charge density, and at this point electric field is asked. Okay, and unit vectors are also given. Sorry. So first of all, we should know formula for electric field for an infinite long wire, that is given by lambda divided by 4 pi epsilon naught r and r cap. Okay, and r cap is r vector divided by mod r. So put this here, electric field will become lambda 4 pi epsilon naught r vector and r. Okay, so lambda 4 pi epsilon naught r square and r vector. What is r vector? R vector we can write from this point, a e x cap plus b e y cap, because unit vectors are also given. So we have to write r vector in ex and ey and ez unit vectors form. What will be r? R will be under root a square plus b square. Put these two values in this formula. So electric field will become lambda over 4 pi epsilon naught a square plus b square. Root will cancel out because here it is r square, and a ex x square plus b ey y cap. So B is right answer. Next question is, there is a circular wire of radius r from angle 0 to pi by 2. We have to calculate electric field here at origin. Electric field here at origin. Okay, so let us assume there is a segment or line element of this wire dl, and due to and this dl carries charge dq, and due to this dq charge there is electric field de here at origin. Okay, and de we can write from Coulomb's law, that will given by 1 over 4 pi epsilon naught, and this is dq over r square and r cap. Okay, and r cap is from origin to source. Okay, r cap is from origin to source. So in this formula we have to calculate value of dq, r square and r cap in the form of non variables. Okay, the which are known things. So first of all, let us write r cap. For r cap and r square we need r vector, and r vector how we can write? We can just split it as r cos theta and in vertical component r sin theta. Okay, and r vector can be written like r cos theta x cap plus r sine theta y cap. This can be written like this. And there is a catch in this question. In this formula, the DE formula, this r cap is from origin to source, but here we have calculated, but here it is given in opposite, because this dq charge will due to this dq charge, electric field will be in this direction, and we are measuring it in opposite direction, so we have to take a negative sign. So we have to take a negative sign here, and r vector will be equal to minus r, we have taken common, cos theta x cap plus sin theta y cap. Okay, and easily now we can calculate r cap. R cap is r vector divided by r, which is minus r cos theta x cap plus sin theta y cap divided by under root of r square, and square of negative is positive, so and cos square theta plus sin square theta mod r will be given like this. So this will become 1, and r square in root will become r, and r will cancel r here, so it will become minus cos theta x cap plus sin theta y cap. And for r square, we will mod of r vector square. Mod of r vector is root r square cos square theta plus sin square theta, and square of this, that will become r square, that will become r square. Now we have to, now again we have calculated r square, r cap. Now we have to calculate dq. dq is given by lambda into dl, this line element, and we have theta equal r over radius, so this is d theta, and arc is dl, and radius is r. So from here dl is r d theta, so dq will become lambda into r into d theta. Okay, so finally we can calculate dE. So dE will become 1 over 4 pi epsilon naught r square, and dq is lambda r d theta, lambda r d theta, lambda r d theta, and in place of r cap we have this negative cos theta x cap plus sin theta y cap. So if we integrate this, over 0 to pi by 2. We can calculate electric field easily, and electric field 1 over 4 pi epsilon naught. 1 r will get cancelled. This is r, and lambda. These are all constant. These will come out from integration 0 to pi by 2. What will remain there? Minus of cos theta x cap minus of sin theta y cap and d theta. So from here I can split this electric field in two components, x and y. 1 over 4 pi epsilon naught lambda over r integration 0 to pi by 2 minus cos theta d theta and ey 1 over 4 pi epsilon naught lambda over r integration 0 to pi by 2 minus sin theta and d theta. Okay, and this will become 1 upon 4 pi epsilon naught lambda over r cos theta, which minus sign will come out. Cos theta is sin theta 0 to pi by 2 ey 1 over 4 pi epsilon naught lambda by r, and this is minus cos theta 0 to pi by 2. This is 1, this is also 1. So Ex equal 1 over 4 pi epsilon naught lambda over r and negative of x cap. Ey will become 1 over 4 pi epsilon naught lambda over r and negative of y cap. On combine, this will become 1 over 4 pi epsilon naught lambda over r minus x cap plus minus y cap minus y cap. So this is our final result. Answer. So let's check this in option. So A is correct option. Next question is related to displacement vector, where for a thin straight wire lambda is given. Okay, so displacement vector D, magnitude of electric displacement is asked. So take magnitude of displacement vector is given by epsilon naught electric field. So we have to calculate electric field. E is given by 1 upon 2 pi epsilon naught r. Magnitude is given by this, and also multiplied by lambda. Put it here. So magnitude of D will become epsilon naught multiplied by lambda over 2 pi epsilon naught r, and epsilon naught will cancel out, and this will become lambda over 2 pi r. So value of lambda is given 8 pi into 10 to the power minus 2 Coulomb per meter, and 2 pi, and r is given 20 mm. So 20 into 10 to the power minus 3 meter. Okay, so pi to pi 4, 4 to 5. So on solving we will get 2 Coulomb per meter square. 2 Coulomb per. So answer is 2. So next question is related to Gauss law. Related to Gauss law. So in Gauss law, total flux through any closed surface is given by Q over epsilon naught, and Q is at the center of two concentric spheres. So there is a sphere first, and there is another sphere second, and Q is placed here. So this is sphere 1 and this is sphere 2. So through the first sphere, flux is given by Q equal phi equal Q by epsilon naught, and through the second sphere it becomes 2 phi, and there is addition of charge. There is addition of charge Q plus Q prime, because flux will increase when there is increase in charge. So let's say Q prime charge is increased. This is and divided by epsilon naught. Okay. So 2 phi equal Q over epsilon naught plus Q prime by epsilon naught, we can say. From here this is phi, and it will go to left hand side, so phi will remain. So phi equal Q prime over epsilon naught, and this phi is equal to Q over epsilon naught. So Q over epsilon naught equal Q prime over epsilon naught. Epsilon naught will cancel out. Q will be equal to Q prime. So amount of charge contained in the region between two spheres. So here in this region, that was Q prime was equal to Q. So that will be equal to Q. So B is correct answer. So next question is question 8, and in this question there is electric field passing through this hemisphere with angle theta, and it is asked to calculate flux of electric field that is coming out through the curved surface area. So we have to calculate flux through this curved area of hemisphere. Okay, and radius of this circular disc is given. Radius is capital R given. So let us first do some basic things like extend. So this will also be theta, and theta is between electric field and plane of circular disc. Okay, let's say this direction is x cap, and perpendicular direction to this is z cap, let's say, and I am making this diagram here. This is circular disc and this is hemisphere. Okay, radius is given, and electric field lines are passing in this direction. making angle theta. Okay, so according to Gauss theorem, flux is given by E dot dA. E dot dA. So this electric field is a normal component, normal to surface, but here it is having some angle theta, so we have to take its normal component. So normal component will be E cos theta, and parallel component will be E sin theta. So we have to take this component. Okay, we have to take this component E cos theta. Further, one thing we should know here, flux through the circular disk will be equal to flux through the curved area. So we will calculate flux through this circular disk. So automatically flux through the curved area will be calculated. So put value of E, that is E cos 30 degree and dA. So E cos 30 we can take outside, and because it is constant, cos 30 and dA. So basically integration dA is the total area of the circular aperture, which is pi r square, E cos 30 and pi r square. So cos 30 is root 3 by 2, so that is root 3 by 2 E pi r square. So B is correct option. Next question is 9, where electric field is given, and what is our total charge we have to calculate, and closed in a sphere of unit radius. So radius is 1 and for a sphere. So according to Gauss law, flux is given by E dot dA, E dot dA, and that will be equal to Q enclosed divided by epsilon naught. From here we can calculate Q enclosed, that will be given by epsilon naught E dot dA. Electric field is given, and for spherical symmetry, dA is given by dl theta and dl phi, where dl theta equal r d theta and dl phi equal r sin theta and d phi. Put these values. So dA will become r square sin theta, d theta and d phi, and r cap. Okay, so here Q enclosed will become epsilon naught. Put value of electric field ar cap plus beta sin theta cos phi and phi cap multiplied by r square sin theta, r square sin theta, d theta, d phi, and r cap. Okay, doing dot product, Q enclosed, epsilon naught. So first doing with this, that will become a r square sin theta, d theta, d phi, and r cap dot r cap plus epsilon naught beta r square and sin theta sin square theta cos phi d phi cos phi d theta and d phi and phi cap dot r cap. So here phi cap dot r cap is 0, so this integral will become 0. So q enclosed will be epsilon naught, a we will take outside and we know r equal 1, so r square will become 1, so it will be sin theta d theta d phi. Okay, and limit of theta is from 0 to pi and phi is 0 to 2 pi. So epsilon naught a, first integrating with respect to phi, so that will give 2 pi and 0 to pi sin theta d theta, epsilon naught a into 2 pi, that will minus cos theta and 0 to pi. So here we will get 2, so that will become epsilon naught a into 2 pi multiplied by 2. So q enclosed will be 4 pi epsilon naught and a, 4 pi epsilon naught a. Okay, option A is correct option. Okay, so let's move to the next question, and in this question volume charge density is given for a spherical symmetric geometry. So there is a spherical geometry of radius capital R, and inside the radius for r less than capital R, kr square equal rho r, and for outside here r greater than capital R, rho r is 0, and we have to calculate electric field. We have to calculate r less than capital R. So from Gauss law, E dot dA q, total q, we can assume q, and epsilon naught. Okay, and from here electric field and dA will be 1 over epsilon naught. Here total q will be calculated because from the rho charge density, as we know rho equal dq over d tau, and dq will be given by rho into d tau, and integrate it will give us capital Q, rho and d tau. D tau is 4 pi r square and dr. Okay, so it will be and putting value of rho here, so rho will be k r square, d tau is 4 pi r square and dr, and a surface area of the spherical symmetry is 4 pi r square, 4 pi r square, that is 1 over epsilon naught. K we can take outside, and 4 pi also, that is r5 over 5, that is sorry that is r to the power 4 and dr, integration from 0 to r. Okay, So electric field 4 pi will cancel out. Yeah, and r square equal k over epsilon naught, that is r5 over 5, and r square, this will cancel out, r cube. So from here electric field can be written k r cube and 5 epsilon naught. But uh, there is not such a option. In options it is given in form of q, but here we have calculated in form of k, so we have to replace value of k in form of q. We have to replace k with q. So for that, q equals 0 to r, and rho theta, that will be 0 to r k r square 4 pi r square and d r. Okay, so q equal k into 4 pi, that is capital R 5 over 5. Okay, so k I can write 5 cube over 4 pi R5, and put this k value in electric field. So I will get and its direction will be radially outward, r cap. K is 5 cube over 4 pi r to the power 5 into r cube 5 epsilon naught and r cap. Okay, so in final 5 will cancel out, so electric field will be qr over 4 pi epsilon naught r to the power 5 and r cap. So A is correct option. Let's come on to the next question. In this question, a sphere is given. Its volume charge density is rho, and a small sphere is cut out from this. Okay. Okay. And here at this point, let's say this is z direction. So at this is 0 at z equal minus r by 2, at z equal minus r by 2, this point P, we have to calculate electric field. So first of all, let's see what is electric field for a uniformly charged solid sphere. Electric field is given by rho r 3 epsilon naught and r cap when r is less than capital R. Okay, and electric field is given by rho r cube over 3 epsilon naught r square r cap when r is greater than capital R. So this is for outside and this is for inside. And one thing also, we should note that removing a uniformly charged portion, this portion, is equivalent to adding an equal and opposite charge distribution at this location. It means if we have removed this portion, so a negative charge density is created here. Negative charge density is created here. So this point electric field will be due to the bigger sphere and is smaller sphere. So calculate electric field due to a smaller one first, because this point is outside, from the smaller sphere. So electric field formula, second formula we will use. So that will be rho. Here capital R is radius of sphere, and for is small one, that is R by 2. So that will be R by 2. Okay, rho R by 2 whole cube and 3 epsilon naught, and capital R is distance where electric field is being measured. So distance from here to here is R. So that's why we use R square and Z cap. So that will be the R square will cancel out, 1 R will left over, and 24 epsilon naught. 24 epsilon naught Z cap. For electric field due to bigger one given by, because this point lie inside the bigger sphere, so first formula we will use. So that is rho, and electric field is being measured at R equal minus R by 2, minus R by 2, 3 epsilon naught. So that will be minus rho R over 6 epsilon naught Z cap. So total electric field, combine E smaller plus E bigger. So that will be rho R over 24 epsilon naught minus rho R over 6 epsilon naught. So 24, that will be rho R minus 4 rho R, and this electric field is given, that is rho R over n epsilon naught. Okay, so from here this is minus 3 rho R over 24 epsilon naught equal rho R over n epsilon naught. So 3 will cancel out 8 times. So value of n will be 8. Value of n will be 8. This is asked. So 8 is answer. 8 will be answer. Okay, come to next question, and in this question 3 infinite sheets are arranged in xz plane at position this. So let us first draw. First sheet is at A, second sheet is 3A and 4A, and we have to calculate electric field at 0 to A. It means this is y axis, z axis and x axis. We have to calculate electric field here at 2A. This is minus sigma, 2 sigma and 3 sigma. So electric field due to minus sigma will be in this direction, minus j cap, and also due to 2 sigma in this direction, 3 sigma in this direction. So all three sheets have electric field direction in minus j cap, minus j cap. Okay, so total electric field will be summation of electric field due to all these three sheets. So that will be and electric field due to one sheet is given by sigma over 2 epsilon naught, sigma over 2 epsilon naught. So that is minus sigma over 2 epsilon naught due to first, due to second, 2 sigma over 2 epsilon naught minus 3 sigma over 2 epsilon naught j cap. Okay, and this will be 2 sigma 3 2516 j cap, that will be minus 3 sigma over epsilon naught and j cap electric field. So B is correct option. So let's come to the next question, and in this question a cube is given through which electric field is coming out, is given, and we have to calculate what is the total charge enclosed within this cube through which electric field is produced. So we have to calculate that. We are using Gauss law here, using Gauss law. Okay, so total charge enclosed is given by epsilon naught E dot A. E dot A. Electric field is given, we have to take integral because charge is enclosed within this cube, so electric field is coming out from all 6 surfaces, and we have to take integration for all 6 surfaces. Okay, so let us calculate for first surface, x equal 1. So we are talking about this surface, x equal 1, this surface we are talking about. Okay, so at x equal 1, dA will be dy and dz, and direction will be x cap. So enclosed will be epsilon naught. Okay, and E dot A, electric field is this one, electric field is this one, and dot product of dy dz x cap, we can also write it at I cap, we can write it I cap. So only when will we will do dot product of this dA and E, so only I dot I will survive, because I dot j will become 0. So only, so that will be k 4x square and dy dz, because x is equal to 1, so x square will also become 1, that will be 4k epsilon naught dy and dz, that will be 0 to 1, 0 to 1. This will give us 4k epsilon naught for the second surface, x equal 0. So which surface we are talking about? This surface, which is at x is equal to 0. So its normal vector will be in negative direction, minus I cap. So dA will be given by dy dz I cap with negative direction. Okay, so Q enclosed will be epsilon naught. Again I dot j will become 0. So 4k x square dy and dz. Here x is equal to 0. So at x equal 0, this total integral will become 0. So this will give us 0 for third surface. So we are talking about third surface, y equal 1. So at y equal 1, we are talking about this surface we are talking about. So at y equal 1, dA vector is given by dx dz and j cap. So total Q enclosed will be epsilon naught integral. Okay, here is j cap, so it will also dot product with I and j. So this dot product with I cap will be 0, only this will survive. So there will be 3k y and dx dz. Okay, so this will be 3k epsilon naught, 3k epsilon naught, 0 to 1, 0 to 1 dx and dz. So this will give us 3k epsilon naught. For the fourth surface, y equal 0, y equal 0, which surface? This surface, y equal 0, this surface, the base one. Okay, so dA will be negative dx dz j cap, and q enclosed, because y is 0 in this case, so total enclosed, q enclosed will be 0, so this will give us 0. Fifth one, for z is equal to 1, for z is equal to 1, which surface this is? This is z is equal to 1, the front one surface, this surface, front one surface, front one surface, and dA will be dx and dy and k cap, because dA is in k direction, so but their dot product with I and j will be 0 and there is no k component, so dot product of dA and E will be 0 in this case, because E dot dA is 0. And for sixth surface, z equal 0, similar case will happen, q enclosed will again be 0. So total charge we are getting, that will be q enclosed total will be 4k epsilon naught plus 3k epsilon naught, only two surfaces, so that will be 7k epsilon naught. So total charge enclosed is 7k epsilon naught, so A is correct option. Okay, let's come to the next question. In this question there is a sheet, which is uniformly charged, and there is a charge which is binded with a string, massless string of distance L. Okay, so and we have to tell the value of sigma, okay, in the non-component. So if this mass contains charge q and mass m, so there will be a vertically downward force mg due to gravity, and electric field due to this sheet will be in this direction, E electric field, that will be sigma over 2 epsilon naught. So on the mass, this is mg, this is mg, and electric field is in this direction, E equals sigma over 2 epsilon naught. So due to this electric field, force will be q sigma over 2 epsilon naught. So there are two forces basically acting, one is downward, another one in horizontal direction, and due to result of these forces, mass m is hanged between these, and this angle is given, that is 45. So this is x, this is y, this is in y, so we can apply tan theta will be equal to q e divided by mg. Okay, this force divided by this force, and Q sigma over 2 epsilon naught and mg, and tan 45 is 1, so that will be 1 Q sigma over 2 epsilon naught mg. So from here sigma equal 2 epsilon naught mg over Q. So C is correct option. Okay, let's come to the next question. This question is of Stokes theorem, which states that Stokes theorem, according to this, if V is given, so electric field can be written as negative of grad V. So electric field here is grad negative of grad V, 4x square plus y minus 2 whole square plus z square. Okay, so taking gradient of it, so that will be 4 into 2 x, 4 into x cap plus 2 into y minus 1 into 1 y cap plus 2 z cap. Okay, so electric field at 0 0 0 at origin, it is asked electric field at origin, so that will be, this will become 0, this will, so only this term will survive. So 2 0 minus 1 y cap, that will be minus 2 y cap, so y, that is minus 2, so that will be 4, that is minus 2, so that is minus 4 y cap. D is correct option. In this question we have to find out the potential at center. So as we know, potential is scalar, so it will direct addition, so if we place a charge q here, so a negative charge will induce negative q charge will induce at R1, and a positive q charge will induced at R2. Okay, so first, potential due to q at d distance apart from origin is 1 over 4 pi epsilon naught q over d, and potential due to this negative induced charge at R1 will be inner 1 over 4 pi epsilon naught negative q over R1, and similarly V for outer radius, outer sphere, that will be 1 over 4 pi epsilon naught. So positive charge is induced, so this will be positive over R2, and since potential is a scalar, so we will directly add all three potentials. So V will be VQ plus V inner plus V outer. That will be 1 upon 4 pi epsilon naught will become common, and this will be 1. So Q over D minus Q over R1 plus Q over R2. So this will be the potential. This will be the potential. So option D is correct option. Okay. So next question is 19, and in this question we have to identify incorrect statement. So let us read one by one. The first statement is work done in moving a charge in a closed path inside the region is 0. So work done is given by force and displacement ds. So for a closed path, displacement is 0, ds is 0. So work done is also 0. B option is the curl of E is 0. Yes, this is true. The first one is true. Second one is also true. How second one is true? Because we know the line integral, closed line integral E dot dl equals 0. So it means this can also be written as surface del cross E using a Stokes theorem, del cross E dot dA. This is 0, and this is only possible if del cross E is 0. Del cross E is 0. If del cross E is 0. So electric field may be written as negative of gradient of V. So if del cross E is 0, so it means electrostatic force. And electric field is written as negative gradient of potential. Okay, so field can be expressed as a gradient of scalar potential. Yes, this is true. And the potential difference between any 2 points in the region is always 0. This is not true. This is false. Why? Because any 2 points, potential difference like this is V prime. So potential difference will only be 0 if V equal to V prime, and this is not only the case. There may be potential not will equal to 0 if V is not equal to V prime. So incorrect statement is D. So D is correct. Okay, come on to the next question, and in this question a charge is given and electric field is given. Okay, and this charge in this electric field is moving from this point to this point, and work done is asked. So work done is given by integration of f dot dl, and f is given by q into E dot dl, and q is taken outside. Electric field is given. Electric field is 8r sin theta, r cap plus 4r cos theta, and theta cap, and dot product with dl is dr r cap plus r d theta and theta cap. So Q is taken outside, and here as we can see, R is fixed 10. R is fixed 10. R is not changing. Here R 10 and R here is also 10. So R is not changing. So integration 8 R sin theta, 8 R sin theta, and dr, and r cap dot r cap plus integration 4 R cos theta and R d theta and theta cap. Here limit of R is from 10 to 10 limit. So this integration will become 0 because upper and lower limit are same. And here this is from pi by 6 to pi by 2, pi by 6 to pi by 2. And also here will be theta cap dot theta cap. So this will be Q. This will be Q. 4 R square will taken common, and pi by 6 to pi by 2 cos theta and d theta. This again Q and 4 and R square, and cos theta is minus sin theta. Limit is pi by 6 to pi by 2. It will be 4Q R square, and this is minus 1 plus 1 by 2, and this is minus 4 multiplied by 1 by 2 and Q R square. This will become minus 1 by 2. So I have multiplied it here. So minus 2Q R square. So let's put values. Minus 2 multiply Q is minus 5 multiply 10 to the power minus 6 microcoulomb, and R is 10 square. So that will become 10 multiply 10 to the power 2 multiply 10 to the power 6. This will become 10 to the power minus 3 joule, and also 1 millijoule I can say. So work done will be 1 millijoule. This will be 1 millijoule. So 1 is the answer.